Okay, so let's continue on by looking specifically at the quadrilaterals, four-sided shapes. We're going to look at the definitions and properties because we're going to use the properties later on to prove certain statements about quadrilaterals. So to start it off, we're going to look at a trapezium. So a trapezium is a quadrilateral. It's a four-sided shape with only one pair of opposite sides being parallel. So in the picture on the right here, we have the trapezium A, B, C, D. Only the sides A, B is parallel to the side D, C, and it's shown by the arrows there, so we know they're parallel. Next four-sided shape is a parallelogram. So parallelogram. A parallelogram is a quadrilateral where both pairs of opposite sides are parallel. So in this example here, this parallelogram A, B, C, D, we have side AB is parallel to side DC, and we also have side BC is parallel to side A to D. There's also other properties of a parallelogram, specifically dot point number 1. Both pairs of opposite angles are equal in magnitude. So this angle here, ABC, is the same as the opposite angle here, and then the same with the other two opposite angles. So let's fill in the blanks. So angle from A, then B, then C. So this angle here, that's going to be opposite this angle, and they're the same. So when we write angles, we've got to write them in the corresponding order. So this A angle corresponds to the C angle, while this C angle corresponds to this A angle here. So initially we had angle A to B to C, and so that corresponds to, start at the corresponding C to D and then A. So it goes angle ABC is the same as angle CDA. So be careful, order matters, make sure you match up with the corresponding angle. And the same thing with the other pair of opposite angles, angle B to A to D is the same as the opposite angle in size. So A corresponds to C, this angle B corresponds to D, and then this angle D corresponds to B. So angle BAD corresponds to DAB in that order. Next property of a parallelogram is that both pairs of opposite sides have equal distance, have equal length. So side A to B is the same as D to C. Again, match up the letter order of your vertices. And then side A to D is the same as side B to C. And another property of a parallelogram is that the diagonals bisect each other. So diagonals are B to D and A to C. The word bisect means to cut in half. So the line BD cuts AC in half, and the line AC cuts BD in half, so that the distance from A to E is the same as from C to E, and that the distance from B to E is the same as D to E. Our next quadrilateral, if you turn over the page, quadrilateral number 3 is a kite. So a kite is a four-sided shape where two pairs of adjacent sides are equal in length. Now, the word adjacent means next to each other. So if you look at the picture here, AB is next to AD, and these two sides have the same length, and they're shown by the dashes there. And then the side BC is next to CD, and they're the same length with the double dashes there. So two pairs of adjacent sides have the same length. You can have a convex kite where the pointy bit stretches out, or you can have a concave where it caves in, the pointy bit caves inside and goes inside. Regardless, your adjacent sides are still equal in length. Other properties of a kite: one pair of opposite angles are equal in magnitude. So specifically ABC, that's the same as ADC because they're opposite pairs of angles. So ABC is the same as ADC. So again, make sure order of your vertices are the same, so they're corresponding. The next dot point is the kite has an axis of symmetry that bisects the non-equal vertex angles through which it passes. So that's just the fancy way of saying if you fold the kite in half this way, then you will get the same shape, the line of symmetry down there. And that's because these angles are not the same. So folding in half, you get a symmetrical shape. The axis of symmetry of the kite bisects the other diagonal at right angles. So this axis of symmetry, because that's where you fold it in half and you get the same shape, it bisects, so it cuts the other diagonal from B to D. It cuts it in half, because that's the word bisect, cuts a line in half, and you have the right angle there as well. So you can see that in a diagram we've labeled that B to this point, let's call it E, is the same distance as D to E because of the two symbols represented there. Our fourth quadrilateral is a rectangle. So a rectangle is a special parallelogram where all angles are right angles in the corner. So here we have a parallelogram. So all the properties of a parallelogram apply to the rectangle, and it, in particular, all the corner angles are 90 degrees, are right angles. So as we say here, all the properties of the parallelogram holds. Also, the diagonals are equal in length, so AC is the same as B to D. And the lines joining the midpoints of the opposite sides are lines of symmetry. So essentially, if as you've done in primary school, if you fold a rectangle in half, you get the same shape. Number 5 is a rhombus. So again, a rhombus is a special parallelogram, but with the additional property that all sides are equal in length. So it's kind of like a square, but it's not a square yet because the angles don't have to be 90 degrees. And later on in number 6, we'll consider the special case of a rhombus, which is a square. So a rhombus is a special parallelogram where all your side lengths are the same. In addition, you have that the diagonals bisect each other at right angles. So AC and DB are your diagonals. They cut each other in half because that's what bisect means. And they cut each other in half in right angles. So you form 90 degrees there. So we say AC is perpendicular to BD. So this symbol here means perpendicular. Perpendicular means 90 degrees. And also diagonals bisect. So you probably can't fit it in. The diagonals bisect the vertex angles. So specifically angle DAC, so this one here, is the same as BAC. As you can see with the two solid dots, which is the same as DCA, which is the same as BCA. So you can see that all 4 angles represented by solid dots, they're the same angle. And then these 4 angles of the crosses, they're the same angle size as well. And also both diagonals are lines of symmetry. So if you fold the shape along DB, you get the exact same shape. And then if you fold along AC, you get a symmetrical shape as well. And lastly, a special case is a square. So a square is a special rectangle where two adjacent sides are equal in length, or in other words, it's a special case of a rhombus where all your corners angles are 90 degrees. So everything that applies for a rectangle and a rhombus also applies to a square. In addition, the diagonals make an angle of 45 degrees with each side because you're cutting in half a 90-degree angle, and each diagonal has a length of equal to root 2 times the side length, and that's due to Pythagoras. So that's using Pythagoras from year 9. When two lines intersect at right angles 90 degrees, we say that they are perpendicular. So we mentioned this before. So these are just 3 other definitions. So the symbol we use is that. Sometimes you might want to even add a little corner angle to denote it as well. When two lines are parallel, we use that symbol to indicate AB is parallel to DC. And when two lines intersect at right angles and one bisects the other, so remember bisecting means to cut it in half, then the line is called a perpendicular bisector. So here are just some definitions of quadrilaterals and their properties.